The question: for a certain organ pipe, 3 successive resonance frequencies are observed at 425, 595 and 765 Hz respectively. The length of the pipe is. So the given speed of sound of the air is 340 meter per second. So organ pipe 3 successive resonances. So that means that is the first frequency. Suppose Fn is equal to 425 Hz, and next frequency, and 2 frequencies is enough for finding the length, but the another next frequency is Fn plus 1, that is equal to how much? 595 Hz. So then another frequency is n plus 2 is equal to 765 Hz. But the frequency formula, so F is equal to I think Fn is equal to Pv by 2L, and Fn plus 1 is equal to, so P plus 1 V by 2L. For determination of length, so the frequencies difference is Fn plus 1 minus F1 is equal to, that is P plus 1 of V by 2L minus Pv by 2L. So Fn plus 1 minus F1 is equal to, so V by 2L common, and P plus 1 minus Pb gets cancelled. Fn plus 1 value how much? 595. F1 value how much? 425 is equal to V by 2L, and 595 minus 425 value is 170. So 170 V by 2L, and L is equal to V value 340 divided by 2 into 170. So that is 340 divided by 2 into 170, also 340 gets cancelled. The length L is equal to, so 1 meter is the option second is the correct answer. And the next question is: a student holds a tuning fork oscillating at 170 Hz. He walks towards a wall at a certain speed 2 meter per second. The beat frequency observed by the student between the tuning fork and its echo is, so beat frequency, and beat frequency is equal to, here two frequencies. One is the frequency towards minus the frequency away, then we get the beat frequency. The given data is, so 170 is the original frequency, and 2 meter per second, this is the source of sound velocity, and velocity of sound is the 342 meter per second. Okay, so the determination of beat frequency is the difference of frequency of towards the sound and away from the And so frequency towards formula n into v by v minus vs. So that is equal to n value how much, 170, and velocity of sound is 342 divided by 342 minus velocity of source is how much, 2. So that is equal to 170 by 342 divided by 340. 342 divided by 340, I think 171 ja and 172 ja, and 342 means f towards is equal to 2 1 ja and 2 7 ja and 2 1 ja. So towards edge 171 hertz, and the frequency away, that is equal to n into v by v plus vs. That means echo, we get the frequency away is equal to n value how much, 170. So v 340 divided by 342 plus vs. So 170 into 342 divided by 344, and the value, I think its value is after cancellation, that is 169 hertz. But the beat frequency f2 is equal to the frequency towards minus frequency away. Towards value how much, 171 minus away 169 we get. So that is equal to the beat frequency is 2 hertz. So this is the, I think, fourth option. This is the option. The question is, a train approaching a railway crossing at a speed of 180 kmph. Speed 180 kmph, kilometer per hour. Sounds a short whistle at a frequency n is equal to 600 hertz. When it is 400 meter away from the crossing, suppose this is a crossing, 400 away from the crossing, the distance is 400 meter. The speed of the sound in air is, the speed of the sound value, so 340 meter per second. The frequency of the sound heard by a person standing on a road perpendicular to a track. So track perpendicular, so means suppose here this is a person, the distance is the person standing a road perpendicular to a track of distance, this is the 300 meter from crossing here. Then he observed the frequency crossing, the frequency of sound heard by person standing a road perpendicular to track at distance 300 meter crossing. Here the person here frequency you calculate, n is equal to, I think n dash, apparent frequency is equal to how much. Here the source moves towards here, so observer is there. So from right angle triangle, this is 400, this is 300, and we get the 500 meter, and a person it makes the source makes an angle theta. Therefore the source velocity Vs is equal to, we know you should write V cos theta. So V value velocity in 180 kmph in terms of meter per second, we get to 50 meter per second. 1 kmph is equal 5 by 18 meter per second. So then we get 50 meter per second. 50 into cos theta. Cos theta adjacent side you have the 400 divided by hypo is the 500. So 0 zeros cancel, 5 1 ja, 5 10 ja. The source velocity 10 into 4, that is 40 meter per second. So you calculate the apparent frequency heard by the observer. So the formula is moves towards to the observer. Get apparent frequency formula, n dash is equal to n into V by V minus Vs. N value 600, V value what is given 340 by 340 minus source value 40, that is equal to 600 into 340 divided by 300. 300 1 ja, 300 2 ja. 2 into 340, the apparent frequency value 680 Hz. This is the answer. The option 680, first option. First option is the correct apparent frequency observed by the observer. The question is the transverse displacement of string clamped at both ends is given by y of x t is equal to 0.06 sin 2 pi x by 3 and cos 60 pi t, where x and y are in meters and time in seconds. The displacement of the string is the length of the string, L is equal to 1.5 meter and mass m is equal to 3 into 10 power minus 2 kg. So 1.5 means 15 into 10 power minus 1 meter, and the tension developed in the string is tension T is equal to how much? So from this equation the amplitude A is equal to 0.06 and here sin kx, this equation is same as sin kx, means k is equal to value 2 pi by 3 and cos omega t. So this omega t means omega is equal to 60 pi. Then determine the tension. The velocity formula V is equal to under root of T by mu. Mu is the linear mass density, but we know the mu value is equal to what? Mass per unit length. So and V value, V is equal to omega by k root of T by mu means m by L. So that is omega by k is equal to root of TL by m. Omega value 60 pi by k value 2 pi by 3 root of, calculate tension, and L value how much? 15 into 10 power minus 1 divided by mass 3 into 10 power minus 2. Ten power minus 2, 10 power minus 2 goes to here plus 2, and we get 150 and 3. Pi gets cancelled. 2 1 ja, 2 30 ja, 30 into 3 is equal to root of 3 1 ja, 3 5 ja. Here 0 is there. T into 50. So 90 root of t into 50, squaring on both sides, 9 9 ja, t into 50. So 0 0 gets cancelled. T is equal to 810 divided by 5. So 5 1 ja, 5 6 ja, 5 2 ja. So tension units is Newton. This is the answer, 162 tension. The second option is correct.